Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3746, minimum string length after balanced removals. Okay, so basically you're given this string of S and it only has two letters, A and B. And you're supposed to remove all the substrings until you can't, as long as the frequency of A's and B's in that contiguous, because substrings are contiguous substring is the same, and then keep doing this until you can't anymore and return the length at the end. Okay, so let's just go ahead and try to follow those instructions. So let's say while A is in S and B is in S, then still a possibility that we have to remove, right? And then let's just go ahead and do this. Let's make this a list of S because strings cannot be modified. So let's call this in current and in current. So for J in range, I length of current. So let's count the frequency of the substring. So cur of J plus equals to 1. Cool. So at any point, if C of A is equal to C of B, meaning A and B have the same frequency in that contiguous substring, so each substring, all the way to the end, right? Then we're just going to perform that delete operation, right? So in that case, we can just say current reassigning this list to everything before the current pointer and everything after the pointer, right? Because a current sublist has to be destroyed. And then we break it, and at the end we can just return length of current because we're doing this as many times until we can't. So just following exactly the instructions described. And so while this works, this is really slow because this is n squared and this is n by itself searching for the letter in the list, and then this by itself list reconstruction is also n squared. So I estimate the time complexity to be about n cubed. Yeah, so n cubed, that's pretty bad, and so we can definitely do better. So the way I decided to optimize this was to make some observations. So if you closely look at the examples, so let's take this example and let's take a couple examples and here. So 1, 0, 4. Notice here that as long as, for example, A has a larger frequency in the whole string than B, or in this case, it has the exact same frequency, 3 A's, 3 B's. So we can pick any of them. We're just going to keep deleting. Let's say as long as we have a B, we're going to keep deleting an A, right? And then we're also going to delete the B. So the biggest frequency minus, if they're both equal, then it's going to be 0 because they both cancel each other out, right? So that's kind of the insight that I came up with. And here, because there are no B's, then we're just returning the string. And then here, A is bigger than B, right? So as long as there's a B, we're just going to keep deleting an A, right? As long as there's a B, keep deleting an A. And then at the end, we just get 1. So yeah, so that's basically how I came up with my solution. So let's do that. So counter of current, let's go ahead and count these frequencies, and then we can just say if C of A is bigger than or equal to C of B, then A is at least, right, equal to, if not bigger than B. So in that case, we would just say we want to return the bigger minus the smaller frequency, 3 A's minus 2 B's. So return C of A minus C of B, right? Otherwise, if this is not the case, then we're just going to return, let's come up with another case. Let's say this was a B instead, then we would just return C of B minus C of A, right? And so let's run this. Okay, so C, let's run this and submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video, and thank you for watching.